through which they overcame this problem, right? So that is what I'm going to talk about today. And so what we'll see is like how to systematically approach the project planning, management of different processes and tools in order to develop a large scale project. Now, my definition of large scale project will be like a project through which they so my definition of a large scale project will be a project that span across semesters and departments. Okay. So the project which I created in final year was a project which was in combination with civil department. So our project was not just a CSE project, but we were having some civil department students as well in our project. And the software which we created was finally consumed by the student of civil department, and they were running their project on top of that. So it was an interdepartmental major project, and that was completed within 6-month semester duration, but it might as well have spanned across semesters. So that is what I'm talking about, a large project. And we'll see like how we can manage that in academics. Okay. Now, as a starting point, I have assumed that we already have the large scale project topic which we want to manage, but still I would like to share some insights on like if we don't have that project topic and we want to really create a project that creates impact, so how we can break that down and how we can decide over that topic. So what usually happens with the students in the final year is like they don't have any idea of what they want to create and what will create an impact. So they end up searching stuffs online and creating those old kind of re-implementing some old ideas like managing library management software. Maybe nowadays you might have seen that students try to create machine learning projects and artificial intelligence projects, but those are not really what the industry needs right now. Industry might have finished working on those projects. Okay. So basically the problem here is like the students in the final year, they lack the project idea. So they don't know what to create and what can create an impact. So the major ideas that we can help here are there could be in-house requirements. So something like these are very basic examples, but something like college website, e-waste management, some online learning portal which the college want to create now, or maybe if they already have, so they want to develop on top of that and build some more infrastructure and add some new features to that. So these could be in-house requirements where students can work. But even better than that could be the academic research. So if there are MTech faculties and MTech students and some PhD students which are already doing PhD from the college, and they have some academic research topic which they are working on. So we can ask a final year student to pick a topic from their research, and while they do research, the student can try to implement that research. So that is one way. Now, before creating this slide and before coming up with these major areas, I had a discussion with my colleague who is in US and he has done MS. I discussed this with a couple of colleagues actually, and I asked him like I asked them how the way they decide on a particular project. So is the college providing them project topics, or they are deciding on their own, and what is the way there? So these are the 4 categories that I derived based on their discussion. So this is something that the global academic institutions are following. So it could be academic research, then there could be industry tie-ups. So our colleges can have tie-ups with industries, and there is some noise on call. So we can have industry tie-ups and we can get some topics and projects which the industry is working on right now. So that could be the one part. And finally, the global issues. So which are,
Sagar, you please unmute yourself, please.
Sure. Okay. So am I audible? Okay. Hello. Am I audible now?
Yeah, you are.
Yeah. Okay. So, or it could be global issues like the COVID-19 and some environmental issues that we want to tackle. So all in all, like what I think is we can divide the final year major project into these 4 areas, which we can finally ask students to develop. Now, majority topics must come from faculty. So this is what happens in global institutions as well. And the reason being, like, students are not aware of what is going on in industry. While faculties are already in touch with industry people, they have their alumni, they have their colleagues already working in different industries and sectors. So they are better aware of these topics as compared to the students. And the topics that student usually bring into play, so those topics might not create that much impact. I mean, there could be some exceptions. There could be some topics which are really innovative and we consider them. But this is like a suggestion from my side, like based on my discussion with colleagues. Like, majority topics should come from faculty so that we really give them some challenges and some areas to work on which can create impact. And like I said, the large project may span across semesters and different departments. So we need to handle that. Now, how do we manage this in college? In industry, we have teams, we have managers, and basically a whole human resource to work on projects. But how do we do that in college? So this is what I came up with, like based on the industrial architecture of the teams. I thought of, like, why not use the same architecture and try to incorporate that in college if we want to create and deploy large scale projects. So we can have something like a program manager on top, which is definitely long term. When I say long term, so this program manager will last for the entire duration of the project. Now, the duration of the project could be 2 years, 3 years, 5 years, whatever. So this program manager will be a long term management from a long term management perspective. Then program manager can in turn have project managers under them, which could be department specific. So if these are interdepartmental projects on a large scale, so we can have a project manager from each department, who may or may not be long term. So that is up to them. But there definitely needs to be someone who is aware of the project for the entire duration. I mean, that helps a lot. Finally, under project manager, there could be module leads, which could be area specific. Like if let's take example of a project where people from computer science and civil engineering are involved. So there could be two project manager, one from computer science, one from civil engineering. Inside computer science, if we are working on backend and front end, so there could be a module lead who is assigned to a front end, and a module lead who is assigned to backend. And then the engineers, which are the students basically working on this front end and back end. Okay, so any question on this slide? Okay, so and here, like, we can see from the color combination, so the program manager needs to be long term. The project manager and module leads might be long term, or they can move from one project to another based on their priorities and workload. And then finally, the students, which are definitely short term. So I'm assuming, like, a student works on a project for a particular semester. Okay. So how can we do this? So, like, there is a term called plan of record, and this is a generic term. So first of all, like, what we need. So we on a high level. So this cartoon image I have put as a joke. Like, is this a project plan? So no, this is plan of a plan. So we basically need a high level plan to uh, in order to start working on that project. Like, what will be the project concept and idea, what will be the high level timelines and releases, whether they will be per quarter, per semester. How that will be. Then modules from different departments, maybe, and even from different areas like back and front end and all. Then deliverables, what are we going to deliver in this project? So the binaries, the source code, documents. So what all things we want to deliver. Then the quality management software and the human resource. So basically the entire division of quality management, and some PICs, like person in charge. Yeah. So is there a question? So I see a hand being raised. So I can't hear anything. So if you are speaking, so can you please unmute yourself? Okay. So then we will be having some person in charge of different modules and different areas. Then finally, we'll be using some tools. So Now, the way we will create this plan of record, so this will be a presentation. So this will be a slide. This will be a set of slides where we will put what is the overall concept, what are the high-level timelines, modules, deliverables, quality management, person in charge, and tools. So you can see these seven to eight slides as a high-level plan, what we want to create. And this again is the majority times, this is the work of the program manager and the project managers. So this should come from them ideally. That what is that we want to create. Then the scale. So basically the project timeline and release milestones. So we want to clearly mention the actual timeline that we want to follow. So this is how industries work. So they know that they have to release a product maybe 1 month down the line. So they put a date, they put an actual date over there, and then they try to follow up every week that what is the progress. And then finally at the day of release, it may go on a day-to-day slip, or it might be ready, which is the best case scenario. But the main point is like we need to have an actual date in the release timeline and milestones slide. Okay. And the way we can break down releases are either we can break down based on features. So what will be the feature set in the first release, then second release, third release. So third release can have more features as compared to first release. So that is one way of breaking down the releases. Another way of breaking down the release is scale wise. So how many users are we targeting in the first release? So maybe if we are, let's say we are developing an online gaming platform. So we can say that in the first release we are going to support only 100 simultaneous users. Then in the second release we might support 10,000. In the upcoming release we can support 1 lakh simultaneous users. So the scale basically at which the project will operate. Then performance wise, so what will be our performance? So we can say that in the first two releases the performance will be maybe 30 fps. We want to cap that on a 30 fps, and then in the upcoming releases we'll move to 60 fps, 120 fps, like that. So performance wise we can also divide our releases, and we can use a combination of course of these three. So that is how we'll divide our entire large scale project into releases. And we know that we cannot handle the entire project at once. So if we break the project into logical releases, we can might as well implement one release per semester. So a group of students will be working on the release one. Then there will be group of students who will come and they'll work on release two of that project. Basically new features, bug improvement, bug fixes, and all. So likewise, it becomes easier to divide the project into releases and then handle that. And the phases which the project will go through will be the alpha phase, where only the internal teams are getting the project. They are testing that, using that, and finding out issues and all. Then the beta phase, where we expand it to some limited set of external users, where we give them that project and product, and they use it, and then they tell us if they are facing some issues and all. And finally the production state, in which we will roll out to the scale of the user that we have decided, and which will be the end users basically. And finally the versioning of the project. So what the industry is following as of now, at least in software, is the semantic versioning, and we need to version them in major, minor, and patch. So basically XYZ. So X is the major version, which will change when we most likely we change that when there is problem with backward compatibility, and we want to develop something which might not be backward compatible and having some major set of features. Then there will be minor releases where we just give some feature updates and stuff like that. And there could be patchworks which we release to fix some existing issues in the existing release. So likewise we can name our project, and this is how industry is doing it. And
Agar,
yeah.
there are some few questions by the participant. If you go to chat box, you can
Okay.
please answer them. If
Sure,
it's possible for you in between the talk.
sure. Okay.
Yeah.
So can we use agile method for college project? Yeah, definitely. So point is like, see, agile, waterflow model, all of these models, agile is the best model that people are working on nowadays in industry. And even they kind of follow some hybrid model. So the point over here is not about the overall method that we want to use. We can deploy different methods, that is for sure. And agile method works best where we have weekly sprints, and we want to do some we have a quick turnaround time between developing something, testing that, and then coming back to the developer that you have to fix this thing, fix that thing. So agile method works best, but then that requires a very close follow up as well. So when we do that in company, when we want to work on some project which we want to develop very rapidly, so we usually have daily stand ups. So we have daily meetings on that project, sometimes even like twice a day. Like we start what we are doing today and then what we have completed. So it is all about, we might have to increase the frequency if we follow that method. Otherwise, we can be on a high level, we can use a very traditional method for now, where we put our entire project into these this presentation that I'm giving, like on a high level, and then do not restrict ourselves to any specific method as such. Like, okay, we'll be doing daily stand-ups, or we'll be doing completing one milestone and then coming back, finding issues and then fixing it. Instead, we can be neutral on the process. So let's create that release by release, because faculty might have a lot of work in their bucket, as well as students might have the academic courses, right? So their examinations and all. So does that answer your question? Okay, so I'll keep my chat box aside. So please raise a hand if you put anything in the chat box, so that I can come and answer the question. So okay, then like we saw, so if I go to the previous slide, so this plan of record could be a presentation with set of slides. So the project timeline could be a diagram. So we can create this diagram and we can share this diagram. Okay. And finally, the feature list. So this could be a spreadsheet. And so this is a very simple spreadsheet. So if you see the cartoon on the right side, so what we essentially want to do is, like, when we are releasing something, we want to go through certain checks. So like if we are starting to fly the aircraft, so we sure have some checklist, like, okay, engines are working, wing flaps are working, fuel is working, we don't have any personal anxiety, and then landing gear is working. So we know, like, all of these things are working, then only we'll start the flight. So similarly, we can have set of features in a project, and then we can in the columns we can have something like the name of the feature, then the owner of the feature, then the target version, so whether we are targeting that in 1.0, 2.0, like that, and whether it is ready to be tested, and then whether it is tested, which means it is ready to be deployed, and if there are any issues related to that, so then the issues. Okay, so so any questions here? And this needs to be a spreadsheet. So this could be a simple spreadsheet. We can create multiple tabs in the spreadsheet with different releases, bring down the features into releases. But finally, we need to have this so that we have a clear cut understanding of what all features will belong to which release and whom will assign these features to. So likewise. Okay. So this is about the feature list. And okay, for process, then we'll dive into the quality management. Now, one important this usually we ignore in college projects. So we say that why it is required in college projects as such. Now this may depend on the fact and the question, like, do we really want to develop quality projects? So if we don't want to develop and send quality projects from our colleges, then sure, we don't need quality management. But if we want to target quality products, then yes, we do need quality management, as well as we can ask the student to we can make the student aware that there exists a quality management domain in industries, and what all things you do over there. And this is very important both for QA and developer. So like, it doesn't matter what role you play in the industry, you should be aware of the testing your product goes through. Okay, so there are a lot of stages where this project goes through. First of all, the unit test. So as and when we develop some feature, and as a standalone unit of that feature, we should definitely have some unit test. Then we should have functional test, which test the overall feature and not the unit part of it, the overall feature. So this will be functional test. So maybe if we are working on computer science and civil. So the entire front end might have one set of functional tests, and the back end might have another set of functional tests. And when we combine this front end and back end, so that is where we say that we are doing integration tests. So we are checking the front end and back end together now, not as an independent component, but rather than an integrated system. And then finally, we have the end-to-end test. So the final project, which will be a combination of what civil students are doing and the computer science people are doing. So civil students will try to put their data and see whether the project works fine for them or not. And there are two methods which we call open box and closed box. So which is the newer nomenclature sort of to the white box and black box. And so what essentially happens in there is, like, for open box you have the code available, for closed box you don't have the code available. As a part of academic projects, so I would say the open box works the best. We want students to be aware what is happening internally, how the code is written, try to break that code and stuff like that. So that is something that works, and that should be there. Finally, who should test the product and project? So there is this nice picture about that. If a developer tests that system itself, then yes, he understands the system, but he will test it gently because he has developed that project, right? So he or she will never try to break that project. And developers are basically driven by deadline. So you have asked an engineer to deliver that particular feature on a specific time, so he or she might not try to focus on breaking the product or testing and fixing all the parts of it. Rather than, they'll focus on delivery, they'll focus on the deadline of that project or the feature. But an independent tester, as in a QA, there is a disadvantage that he or she must learn the entire system, that how it works. But then they'll try to break it because they have not written it, and as we can say that they don't have any emotions about it, so they'll try to break it. And they are driven by the quality. So they don't have deadlines. They I mean, really, QA is never having any. Even in industries, QA don't have a deadline as such, that when the project is going to deliver, they have deadlines on how much time they want to test that project, but they don't have any deadline of project delivery, right? So they are driven basically by the quality. So they'll always say that this project quality is having 80% quality score, I don't want to release this. So they'll straight away say that I don't want to release this project. Now it is up to management team and development team to look into the issues, fix those, and then again give it to QA to test it. And finally, when they say that, okay, this is acceptable quality score, maybe 90%, 95%, then they'll say, okay, this is acceptable, now we can release it. So they are basically driven by quality. So this is the major difference in, like, who should test. So ideally, an independent tester is the best tester. Okay. So any questions so far? Okay, nothing in the chat box. So we will proceed. Now, talking about the tools. So this was about the process. So let's quickly go through the things. So there are only 4 things as of now. Okay, so I think there is a question. Is there a question? Okay, so there are basically 4 things, like plan of record, project timeline, feature list, and quality management. Basically, only these 4 things needs to be there as a part of high level process to try to create a large scale project. And then we can dive into the tools. So now this was about managing the process. Now we'll see, like, what exact tools we need to manage these projects. So on the very first place, we saw that the POR will be a presentation, the plan of record will be a presentation, the timeline will be a diagram, the feature list will be a spreadsheet. There could be README documents which we want to attach to the project so that the end user can follow those documents and then use the project or consume the project. So those will be simple documents. Now, where can we get this? So a simple answer is Google Drive and Microsoft Office. So all of us are using this. But what happens is, like, these Google Drives and Microsoft Office are the best way to share work across the project team members as well. So here I'm not talking about the local copy of the Word or the local copy of the presentation, rather than have that directly on the Google Drive and then share it across with your team members and like that. So we really want to push students to put them on Google Drive or Microsoft Office Drive rather than having a local copy. It will also become easy for the faculties to put comments on the slides that fix this, fix that, and all, and then student can go back, fix them, and mark the comment as resolved. So there is a lot of tools that these things provide online, like collaboration, then versioning, so we can have versions of the presentation, version 1, version 2, version 3. We know what is changed between version 1 and version 2, so things like that. So it is really the time we move to these online platforms, like if not already. So if we are already doing that, that is great. Then project management. So now comes the task of like how we are going to track what task we have assigned and to whom. Okay. And then we will also like to do release management. So like what all features will go into a particular release, the remaining feature will go into the next release. Similarly, we might as well, like the question was asked regarding agile. So in agile, mostly we follow sprints, and those sprints are quick sprints. So we would like to focus on sprints, like, okay, we want to handle these features, these 4 or 5 features, we want to target that in these 2 3 days, and then let's wrap it up. So this is our sprint. So this week is a sprint, so let's finish that. And we want to manage backlogs as well, like what features are pending, from how long they are pending, and whether we'll be able to finish them in time or not. And then the overall workflow a feature will go through. So the feature will be, maybe a feature will be in requirement ready workflow state, then code ready, then QA tested, right, and then finally deployed. So these will be the workflows that we would like to manage. And where can we get that? So Atlassian Jira is a platform where we get that. Now this is a paid platform. There are open source alternatives and free alternatives to this platform, which we can leverage in academic institutions, but like I haven't spent time in researching those. So that is something there. And Atlassian Jira is something that industries are using, but as far as I know, that is very costly platform. Okay, so any questions here? Then comes the code and issue management. So what do we need? So like, okay, we have now the plan ready, we have the feature list ready, and students started working on the actual project. And what do we need? What do we need there? So we need version controls. We want to, like we saw the semantic versioning. So we want to semantically version our features and project. And then branching, we would like to maintain different branches, like a stable master branch, development branch, and stuff like that. So then we want students to collaborate. And in college, basically we really want to track uh, what student played what role. So we see that there are 5 to 6 students in a project, and we don't know who contributed to which code. So if we are using some version control system, and we enforce them to put their projects online on things like GitHub, GitLab, or Bitbucket, so we know who is contributing to which code. So there is a clear separation of activities based on the users on these websites or on these tools, basically. So that is something that we can have advantage, because we really want everybody to contribute to the project. We don't want one person to burden and other people to take the credit, which usually happens. I mean, it's a dark reality, but we need to accept that that usually happens in academic institutions. And if possible, we need to avoid that. And because finally then the point is, like, this doesn't happen in industry. So if the same people, they are going in industry and then they are assigned some project, so it won't happen in industry that they are piggybacking on someone, relying on someone to finish their work. So that is not going to happen there. So they'll suffer later in the industry. So it is up to us to make sure that they have this habit of contributing to the project, and not just to the documentation, but to the actual code of the project as well. So we would like to have access control over the code. Like, we want certain people to be able to look into certain modules if that is a safety critical project, and we are developing something which is having sensitive information and stuff like that. And finally, the issue management. So if there are some issues which we want to work on and which we want to fix, so the issue management system. So we can log issue, we can revisit those issues, we can mark them whether this issue is fixed or it is postponed to a particular release and stuff like that. So we get all of these things free of cost on GitHub, GitLab, Bitbucket, at least for academic institutions. So we really need to motivate our students to put their code on these tools. And then it also, so based on my discussion with my colleagues in US and all, so when students start putting their code online on GitHub and Bitbucket, it also helps them build their profile over time. Okay. Now we are not talking about just one project, we are talking about all the projects including minor projects, and as we'll see in the later slides that what is a recommendation that I created. And then we'll see that if students start putting all of these projects on GitHub, GitLab, and or Bitbucket, they can build their profile uh, over time, which will help them later in their career. Because what students end up doing is, like, when they want to apply abroad, then they'll go on and create their GitHub profile maybe in a month time frame, and try to put some hacks like copy paste code from here and there. So that will not help in long term. And even these websites, they'll show the activity, so they'll directly break down the whole year activity, and they'll show literally that the entire activity is done in the month of October. So the student was not at all active from the previous year. So we really need to enforce this, and motivate students to do that while in second year, third year, fourth year, so across all the years. Okay, so any questions here? Okay. Nothing on the chat as well. Okay. Now, finally, the communication and meeting. So this is something that we might have already experienced in terms of when there is this lockdown for COVID-19 situation. But this happens in company, like we have this since the inception of the projects, right? Since I joined, from that time, I saw that there are a lot of communication tools which are already there in industry, and they're using this. I mean, nobody thought about lockdown, but still they have these tools. So the important thing is, like, we need the project people to be in touch with each other even when they go home. So like most of the time what happens is, like, we end up working on a project when we are home. So while in college we attend lectures, we attend practicals and all, so we usually don't get time to develop the project, and we only work on project when we head home or head to hostel or our rooms. So we need some mechanism for students to, some groups basically, where they can communicate. Now WhatsApp is something there, but more professionally, like with some other features, like attaching Google Drives, attaching code repository, notifying on calendar and stuff like that, that could be accomplished with a tool called Slack, which again is free, and Google Meet. So we can Google Meet for virtual meetings. So we can use these tools, and we can ask students to join on these tools and then start collaborating there, start communicating there in order to come up with a good project and help them, be in touch with each other, get their problem solved easily. And this practice will help later in the academic, in the industry as well. So, but this is something that is definitely required for a large scale project. So we need people to be in touch with each other. Okay. And finally, like where to host. So nowadays, this is a cartoon, but which really explains what is going on in industry. So cloud is the answer to everything. It is literally the answer to everything. Everything is going in cloud. Now, whether we want to target, so it depends on our project, like what is our project basically. But usually we can break down into some high level requirements, like do you want to do some general purpose computing? So basically, are we crunching some numbers? If we are crunching some numbers, we want general purpose computing. So that is one thing. We might want some storage. So maybe we are creating a hosting site where we are hosting some files and all. So we want storage. Then we want database. So it could be an SQL database or a NoSQL database, or we might need a web server. There are a lot of things like authentication, analytics, and uh, some real-time database, AdWords, ad network. So there are a lot of things which are already available in cloud, and we can leverage that. And students need to be aware of these things. And large-scale projects requires this. So we cannot deploy large-scale project on a local computer. We cannot even imagine to do that. And where do we get this? So we get this on Amazon AWS or Microsoft Azure. students, as far as I know, students, they get some free account, the EC2, I think, instances on AWS at least for a year. And after a year, they will charge. So that is more than sufficient for us to work on a project for a specific student point of view. And similarly, we might as well have some student discounts available on Microsoft Azure. Now, when it comes to now, this again is from my personal experience, but I would really like to share that with you guys. So it is like when we go on and create a project and we want to host something on cloud or purchase something online, a licensed version. So we give it a second thought, and most likely we'll deny that, and we'll not do that. So we'll not purchase a license AWS account or paid AWS service and then use it. Rather than that, we will try to have some local solution. But when it comes to the purchasing something from stationery, so like the binding uh, of the report copy, and having some printed pages and stuff like that, and even if we want something in additional to that, so students are more willing to spend their money on those fancy items which are not really helping them in professional way. And they'll avoid spending their money here online on actual services which they are going to use in long term in industry. So it is up to us to motivate them and shift their focus from these fancy items which really will not help them in long term, to these items which where they can productively spend their money and learn those tools online, and then finally that really can help them in industry. So the point here is like, when we, and even if we are getting some funding from, like we said in the first slide, right? So if we are getting the projects from some industry tie-ups or research, academic research, so we do have some fund associated to that project, right? So we can spend that some of that fund on online services, get a good platform for the students to work on, and then students can work. Okay. So that is from the server and cloud point of view. Okay, so any questions here? So let's revise once again very quickly, like what are the tools? So we have document drives, we can leverage Google Drive, Microsoft Office, and we need to motivate students to use them for presentations, spreadsheet, documents, and diagrams. We have Atlassian Jira and some related open source and free tools where we can track those tasks, manage releases, manage sprints, manage backlogs and workflows. We have systems like GitHub, GitLab, and Bitbucket, where we can track our versions, branching, collaboration, access control, and issue management. And we have communication tools like Slack and Google Meet. And finally, we have servers and cloud infrastructure like AWS and Amazon Azure, which we should motivate students to put their project on. So this is from the tools point of view. Okay, so now we have the process, we have the tools, and but what we don't have is the workforce. So when we, so let's say like you guys come up with a good project which you know industry will need this. You have maybe researched yourself, and then you want students to work on this project, which is a big project, which is a large project. But when you will give this project to a final year student, what may happen is the final year student will say that, okay, I'm not afraid from the project, but I'm just not ready. Now this happens. Why? Because the student so he has only worked on one minor project so far, which was his or her idea, and which probably he saw online, and he probably downloaded the code as well, like we don't know. So he has only worked on one minor project so far, that too not fully, and then we want him or her to work on a very big project. So we don't have the workforce ready, right? We don't have that. What industries usually do is, they, when students get out of a college, they put them through a training period, right? A 6 months training period. So they'll teach them all of these tools, they'll teach them the processes, they'll actually teach them programming once again. I mean, I don't know what is the use of that, but if they are doing so, we are definitely lacking somewhere in academics. So they'll teach them all of those things, they'll put them through the training program, and after 6 months, they'll assign them to a project. So that is something that we want to do in colleges. Okay. Okay, so there is a question how to formulate project problem. So I'll come on that one. Okay. Um, Now, so what should be the plan? How we can create this workforce and make sure that when we are in final year, when we want to give the project to a final student, he or she is ready for the project. So I have drafted a plan based on what is followed globally. So what we can do is we can have at least one project per semester. Okay, at least one. So let's say in this semester I have subjects like C++, database, and operating system. Now we know that a project in operating system will be a big project, and student might not be ready for that. But a project in CPP can definitely be done, right? We can create some small project, ask student to create some small project in CPP for that specific semester. Now this could be second semester, this could be third semester, whenever they have the C++ subject. So, but the major point behind this is like this topic should be common for all, and it should be done by individual person. So all the 80 students in class will work on a single topic on a single language, and at the end of the semester they'll submit this project. Now the objective behind this is to teach student how to make projects. Now the faculty might already be having a project template. He or she might already be aware like how a good project looks like for this particular sub topic, and then we can guide student to follow that path, divide the project accordingly, and then build that project. So likewise, there should be one project per semester which will be common for all. Okay. Now we know that we might as well argue on this point that students don't have enough time. They are busy with their academic career and all. Academic studies like subjects, theory, practicals, all of these things. But let me tell you this: like industry outside college is harsh, so they don't mind assigning work which the employee has to do once they get home. So even after going home, they are still busy completing their work, and that happens. So during the academic phase, yes, we should definitely try to relax some things, and we should formulate like, okay, how much time a student is having in the entire day. He or she might need time for his personal work, some hobbies, etc. We should consider that, but we should also consider that we should not relax them too much that they are busy in their hobbies and they are not focusing on their academics at all. So that is something, if we give them some strict deadlines, some semester projects, so they'll be working on that. And then a minor project which we usually have in sixth semester, I guess, and that can be any project idea, and the student can come up with that idea. Now the objective here is we let the student explore the global issues and industry. Okay, so now this topic will not come from faculty. This topic will come from the student themselves. So they'll try to come up with an idea. They'll go online, research online. But remember, if they have already worked on maybe 2 to 3 projects per semester, by the time they get a minor project, so they'll already be aware of the process. They'll already be aware what needs to be done. So they'll be in a better place to research the global industry on topics, on the actual topics, rather than the implementation. So implementation, they are aware now. So they'll search and look up for a topic, and then they'll try to implement. So the objective here is to let student explore the global issue. And finally, the major project which we are talking all about now in this presentation, so which will be a quality project that we want to deliver outside the academic institution. We really want to make an impact. We want that project to be highlighted that, okay, this project is developed by the Computer Science and IT department of KDK College of Engineering. So we really want to create that impact. So that should be the major project and focus of major project. Now, the point here is like the students should go through at least 4 projects before the major project. Okay, that is the experience they should have for creating a large scale project. And all these projects, they should upload on GitHub and Bitbucket in order to build their profile. Okay, so that is the systematic academic project plan which we can have to get that workforce, to generate that workforce. Okay, now okay, I'll come back to the question. Okay, I'll come back to the questions. So just one last slide remaining. So knowledge transfer and project handover. So now we are talking about a project which will span across semesters, but the students are available only for a year in the final year, and then they are going to leave the institution unless they are, having some backlogs and all, which we don't want to consider. So the 8th semester students, so how we can divide this? So we can create a project semester overlap where 8th semester student basically can work on the major components of the project. They can develop the components, write actual code for that. And the 6th semester project can, 6th semester group of the corresponding project can focus on testing the project and finding and fixing the bugs. So likewise, let's say we have five students working on a project in 8th semester, and we have one-to-one correspondence of five students from 6th semester helping them with testing and bug fixes. So these 5 people from 6th semester will be already aware of the project, and when they go to 8th semester, they can pick up the leftover work and then start working on the next release. So likewise, we can overlap the project across semesters, and then we can target a large scale project. Then definitely we need to have weekly meetings, release meetings across the larger team. So if the projects are divided um between departments, so then I mean these weekly meetings and release meetings will definitely help. So they'll get to know what are each other's milestones, what milestones are achieved, whether they are blocking each other on features and stuff like that. So that will help solve that problem. Okay, so now is the question slide. So let me quickly open the chat. Okay, so how do we formulate the project problem? So, project problem formulating is, there are two parts to this. One is like when we decide on a particular project, so we know like there is some problem that we want to solve. Okay, and the presentation that we talked right now is assuming that you already decided to create that project and you have divided that across components and stuff like that in order to tackle that problem. Now this formulating project problem and actually dividing that is an in-between task that you want to do, and there are no tools as such available for that. And I mean,
मैडम डाल दीजिए नहीं तो
we
आने
can
लोगे
we can write documentation. The way we do that in industry is like we
नहीं
have a
पहले आप
documentation
इसका डालिए पहले सेकंड
where
सेक्शन
we
आज
break
का
down. Hey, there is
और
some
फिर
noise on your.
थोड़ा सा ब्रेक
Can you
होने
guys
के
mute,
बाद
please? Okay. So, there is no tool as such available to formulate the problem, but we can sure divide the problem into what is our overall objective, what we want to achieve. Are there any existing solutions that are available? Are there workarounds available which we can use to solve that problem? If not, then what are we trying to build? And what is the advantage of building this solution? How it is tackling the individual aspect or individual dimensions of those problems? And then finally the technologies that we will use. So if we create this simple document, I think we should be able to formulate the problem, present it to other people, the stakeholders, maybe the engineers and all, and we should be able to work on that. So does that answer your question? Okay. So testing tool freeware. So testing tools is a very generic term. Now it depends what software you are building. So let's say, so I have worked on certain tools which are definitely NVIDIA proprietary, so I cannot name them. But in general, what I have seen online is like when we work on browser automation, there are if we are developing some front end application or back end application, so we mostly want to work on the browser side. So if you are doing UI based testing, then Selenium is something that you can work on, which is not free, I guess, but there could be Selenium alternatives, freeware Selenium alternatives to work on. We have a site called Alternatives. The site itself is called Alternatives, I think, and we get all of the alternative software over there, so which is a good place to start. Secondly, like if you are working on a backend, you are exposing some REST API, then Postman is a free tool that you can use to test the REST API and the backend application. So likewise, what I'm saying, so for CAN bus, if you are developing some automotive application, you have CAN bus on the board, you want to test that CAN bus, then Python programming language itself provides some libraries like Python CAN to be able to test that, do some virtual CAN stuff and all. So likewise, the tools that we want to use for testing really depends on our project scope and what all technologies we are using in our project and what we are doing in project. If we are creating automotive project, that is a different set of tools. If we are creating embedded project, those are different set of tools, maybe to test the unit level software. So for unit level software, we have to test, we have Python unit testing framework available, right? So that is a built-in framework which is called as unit test. there is a framework called PyTest. This also is a framework to which we can leverage to develop some tools to test embedded systems. And then finally, if we are developing web-based applications, we can have Selenium, we can have Postman, so all of those things. So I don't have the list ready now. Maybe if you can drop me an email on what areas you want to test on, I can sure help you with the actual tools which we can use in academic institutions. Okay. Then what is the main difference between Google Meet and Hangouts? Is this a question for me? I don't think this is a question for me. Okay, anyway, like my answer is I'm not aware, and we are using WebEx in NVIDIA. So yeah, I'm not aware. And then this app is used for project presentation. So I don't know, is the question like what I used to create this slide? I mean, it's Google Drive. So I've used Google Slides for that. Okay. What do you think about using Google Colab Jupyter Notebooks? Yes, Jupyter Notebooks are really a good way to work on Python projects in an interactive way, and you can divide your code into blocks, execute each block, and it is really nice to explain someone and give for testing as well, especially from white box testing point of view. Google Colab I haven't worked on, but Jupyter Notebook, yes, definitely it's a go. So instead of writing on a plain in a plain text editor, Jupyter Notebook definitely have its own advantages. And how to measure quality of a software. So quality of a software can be measured across multiple dimensions. Functional quality is one, performance quality is another, stress quality is the third. So that is usually how we do in industry. So functional quality indicates like whatever feature list we just talked about, right? So we can create some test cases for individual features. And let's say you have 10 features and you have 10 test cases for each feature. So in total, you have 100 test cases, right? So out of these 100 test cases, if someone is going to execute the test case and 80 of the test cases are passing, 20 are failing. So we can say that the functional quality of this software is 80%. This is on a very high level that we do, which helps us to track the project. And we can say that the quality is 80%. Now, certainly some of the tests might be very important, which are very basic and which are legacy tests. So if they belong to the 20%, then it is very bad. It is very bad for us. So that usually will happen if there is some regression in the code. Okay. So functional testing is one dimension. Second is the performance testing. So let's say you are developing a web application. So you will like to test like how much time it takes your application to respond. So once a button is pressed, how much time it's taken for response, ignoring the network performance. So what is the time your backend takes to respond? What is the time your front end takes to respond? So things like that. So performance is another dimension where we measure the quality of the software. Now the third is stress. So stress involves like how many simultaneous user can work on your project. They can access your project and they'll get the reliable data. They won't be blocked forever. So stress is the third dimension which we measure the project quality on. So these are the three dimensions on a high level which you can measure the software quality on. Okay. Okay. Then do software metric standards used in industry? If yes, then who do this computation? I didn't get the question quite, like software metric standard. So yes, we do measure on certain metrics. Like metrics are basically, we can even further split the actual test, a functional test or a performance test, into individual matrices. Like on a high level, it could be like on day-to-day basis or on a release-to-release basis, how your software is evolving and what all quality score your software is presenting. So release over release quality measurement could be one metric. Then module-wise quality could be one metric. So these are the quality matrices that we usually take. Then an individual test case could be broken down into further matrices, like for example, a test is performing. So whether it is a positive test or a negative test, then how many positive tests are passing, how many negative tests are passing, and if that is a performance test, so we really would like to divide it into, let's say if you are targeting a game, so what is the FPS of your game, And apart from FPS, what do we measure? So what is the resolution of the game? What is the resolution, like how it is dependent on the FPS that way? Then whether there are some jitters and stutters on the game, what is the experience? Is it smooth or not? So stuff like that. So that I assume is the metrics. Apart from that, like I really don't get what is the definition over here of the software metrics. So if you have a, again on this question, if you have a clear if you put few more points on helping me understand this problem, you can drop me an email. I'll definitely respond to you on this one. Okay, what is regression testing? Okay, so regression testing is a term where, you know, let's take example of college itself. So 8 semester students are working on a project. They create some project and first version is released. Now the students, they graduate and another set of students are working on release 2.2. They put some code in there, they try to fix something, they try to implement something new, and the older thing breaks. So if an older thing is breaking, that means there is a regression in the system. What we usually do in regression testing is, like, for a particular release, we freeze on the test plan. So this release is having this 10 features, each feature is having 10 test cases, so we have 100 tests. Now all of these 100 tests are passing when we release that software. Now, when we are making changes to that software, if some of the test is breaking, we need to monitor that, which test is breaking and why it is breaking. We need to fix that because we want to maintain backward compatibility. We want to maintain that feature in the next version as well. So that, so whatever we do release over release, the testing to make sure that the features of previous releases are not breaking because of the new features implemented or the bug fixes, that is called as regression testing. Okay. Testing during software maintenance. Yes, testing during software maintenance is a very good point. So point is, like, in industries we do that. I mean, I don't know, like, how much maintenance we'll be doing in academic institutions, since we are talking about academic institutions. So but in industries, what happens is the projects get created in 2-3 years, let's say. But the end of life of project is 15 years, 20 years. That project, if that goes to a customer, that customer can use it for 15 to 20 years. So we definitely need to maintain that software. Okay. So here the testing mostly involves, and it depends on how many features are going over time. So let's say you give a software to a particular customer, and then you are not releasing anything on top of that. You are not giving new features. You are not giving any bug fixes, and the customer is happy with that software. You don't need to test that anymore, right? Even though the software the customer is using, you don't need to maintain that, test that. But if there are new features going, there are new data from the customer side which is getting ingested. If it is throwing some production bugs, like some bugs are getting exposed in production over time, so yes, then we need that testing. So it really depends on the lifetime of the software which we are giving and to which customer we are giving. Okay. Test previous features and new features. Yes. So yeah, I mean, testing previous features is nothing but regression testing, what we do. So we want to make sure the quality of the previous features remains the same while we get new features. So this again brings up a new good point, like how we test new features. So most likely we won't be able to test the feature till the time it is implemented, right? But what usually happens in companies, like companies are having developers as well as QA, and both of them are taking salaries, right? They are taking salaries on month basis. So industries want to leverage their time. They don't want to give salaries free, right? Without having them work. So what usually companies do is they'll try to do this process in parallel. So while the feature is being developed or designed, the QA starts participating and they parallelly start deriving the test. Okay, this is a sub feature, or this is a particular metric of that feature or parameter of that feature. So QA start defining the test case parallelly. So by the time feature is ready, till that time the QA test plan itself becomes ready, right? So likewise, at the end of the feature, QA is able to pick up that feature, test that feature, and report any software bug. So handling new features and defining test cases for that is altogether a new area. Okay, I think I have gone through all the questions. If I missed something, so can you please once again put that question in chat box? Okay. If not, I think we are already over time. So I would like to hand it over to Shantanu sir. Sure. I'll put my contact details. Basically, I'll respond on email. So this is my email. I'll put that on box, as well as I'm showing that on the slide right now. You can drop me an email on sagarudasi@hotmail.com. Slack features. Okay, so Slack is a communication platform. You can consider it yet another WhatsApp in order to be able to communicate between different team members. But there are certain features which are definitely way better. So, like for example, in Slack, there are teams. You can manage different teams just like you manage different group. But point is like the team itself are having certain time, certain items which are pinned to the team. Maybe the team structure, some issues which they are working on. So you can pin this item to the teams. Then you have starred item which you want to highlight in the team group chat, and you want to keep that always starred basically. That, and then you can use plugins like Google Drive plugin and some task management plugin as well, reminder plugin, calendar plugin. So you can ping the Slack bot like, remind me to do this work on this date, enter, and then Slack bot will keep this reminder. It will ping you. You can also take voting on Slack, like how many people want to implement this feature, say yes or no. So you will take the voting, it will generate a voting graph. So it is way bigger than just a communication platform. It is really a good thing. Kokomo 2. I am afraid that I forgot this term. Can you, I mean, I haven't heard this term since long back. I'll get back on this one. Okay. Can we create our channels on Slack? Definitely, you can create. In fact, I would recommend you to create. So on channel, instead of channel, first thing that you create on Slack is a workspace. Workspace is something which is the first thing you create, and NVIDIA is having its own workspace. Likewise, other companies which are using Slack might have their own workspace. So you can create a altogether workspace for KDK College. So you can create a workspace for KDK College. That workspace student can join. Then the students can create groups of individual classes, maybe their semesters, their batches, and faculty groups. You can do that, and project groups as well. You can do that. Constructive cost model. No, not giving me any hints as of now. So I'm really sorry on this one. I will get back on this one. Just drop me an email with the set of questions that you have, and I'll get.
Yeah, Sagar, I think it's all
We
kind
are
of.
almost out of time. Yeah.
I guess all the queries hopefully satisfied of the participants, and now that was a really nice session. Now I would like to call Mr. Anup Bhange sir, Professor Anup Bhange sir, to please take over.
Thank you, Harish sir. Sir, am I audible?
Yeah,
Yeah.
you are.
Very good afternoon, all. It's my privilege to present vote of thanks to such a great personality on behalf of eFDP Organizer Committee, KDK College of Engineering. I, Professor Anup Bhange, Department of CSE, would like to express my heartfelt thanks to Mr. Sagar Udasi, sir. Today, we had an opportunity to hear your valuable thoughts about productivity tools and process to manage large-scale software projects. This will really encourage all of us. Your thoughts have enlightened our minds and shown us a new path. Thank you so much, sir, for a great session. Thank you, sir, once again.
Yep. Thanks to all the participants, and thanks for inviting me. It was really great to think with you guys. And feel free to drop me an email. Sure. Thanks, everyone.
Yeah, thank you. Thanks a lot, Sagar.
Yeah. So I'll be dropping now, sir. Okay.
Yeah, please, please.
Okay. Bye-bye. Take care.
Thank you. There is a small announcement for participants. I am displaying a one screen for tomorrow's session. the schedule of tomorrow's session. For tomorrow's session, we will have with us Mr. Shishir Srivastav sir, and the topic is digital transformation approaches to enable communities fight COVID-19 pandemic.
हरीश टाइम बता दे टाइम 9 o'clock.
Especially, please focus on the tomorrow's session's timing. Actually, it is at 9 a.m. It will start at 9 a.m. to 10:30, the first session, and joining for first session will be start at 8:45 a.m. sharp. So please note it down. The timing is, again, I'm giving one kind of reminder to you that tomorrow's timing for first session is 9 a.m. and you will suggested or requested to join us at 8:45 a.m. sharp, please. Thank you.
हेलो किसी का कोई बाद में आया तो देना पेरिस